All right, so I haven't been in for a while, so I thought I would work through a few of these for you. Down here in Part B, we show the free body diagrams, so there's no need for me to draw them. There's the second block, here's the first block, so this is going to be block 2, and this is going to be block 1. All right, so you always want to find the acceleration of the system first. Generally, we draw our free body diagrams. They already did that. So now we just write our equations. So the sum of forces on block 1, the only thing that's going to cause it to accelerate is the tension force. It's accelerating to the right, so it's positive. Block 2 has 2 forces causing it to accelerate. We have the applied force and then the tension force, and that's going to cause it to accelerate, and they're both accelerating in the same direction to the right because of this applied force. Okay, so the easiest thing I think is to use substitution. So we're going to substitute this equation right in here, and we will solve this lovely equation. So we are going to have applied force. We're going to subtract m1a, and that's going to equal m2a. All right, we will rearrange, do a little algebra. Okay, so there's our equation. All we need to do is plug in the given information. We get 360 divided by 40, 36 divided by 4 gives us 9 meters per second squared. It's moving to the right, so we're going to say our acceleration is positive. All right, so our next thing we want to do is calculate the force. Oops. And we will do that next by using the highlighted equation in blue. Okay, so that equation was, or still is, Ft equals m1a. So tension equals mass of object 1, 10 kilograms, acceleration, 9 meters per second squared, tension force, 90 newtons, positive, going to the right. Perfect, all done. Okay. Problem, this one's just a little bit different. We've done these a couple times. You saw one on your little practice quiz. So first thing you want to do is label everything and draw your free body diagrams as I've done for you. And then we want to write the sum of the forces equations. And yes, you need to write these out in order to get complete credit. So the sum of the forces on object 1, the only thing that's causing it to accelerate is the tension force. Sum of the forces on object 2, it's the tension force, which is upward, and we have to subtract the weight of object 2, and that's going to equal ma for object 2. So object 1 is accelerating to the right, and so we would consider that a positive acceleration. Object 2 is accelerating downward, and so we would consider that a negative acceleration. So when we're doing our equations, our first equation, we set it equal to positive m1a. So in our second equation, we just have to make Okay, so there we have our sum of the forces equations. And again, this is a nice one where we can just use substitution. We will use this equation and we will substitute that into our second equation. And we're going to subtract number Let's write that in right there. And that's going to equal negative m2a. All right. So there's our equation, and we want to solve for acceleration. So in order to do that, we need to get our acceleration over to the same side. And I'm just going to do some algebra quick and rearrange and solve for you. Okay, so I just factored out an a, rearranged, moved things around, and then substituted into the equation, and we get an acceleration of 8.2 meters per second squared. So that's the acceleration of the system. If we wanted the acceleration of mass 1, it would be a positive acceleration. The acceleration of mass 2 would be a negative acceleration because it's going downward. But the system, you can just leave it with no sign on it at all. All right, so the next part then is to solve for tension force, and this is fairly easy. We'll go with the highlighted equation above because that's the easier one to plug into. And again, using the subscripts helps us to plug into the correct masses. So M1, that was our 10 kilogram mass, and we're going to multiply that by our newly found acceleration of 8.2 meters per second squared, and that gives us 82 newtons. And we'll just put a plus there, and we're done. All right, so you should be able to follow the steps from before and draw out the problem again, I hope. And the answers should be an acceleration of 2.5 or 2.45 meters per second squared and a tension force of 147 newtons. It's the same setup as the problem and the previous question. Now question 4 is a little bit different. This one we have an Atwood's machine, and we have a mass of 10 kilograms and a mass of 3 kilograms. And they are hanging side by side. And we want to find just the acceleration of the system. So same thing, I'm going to draw the free body diagrams for each, write the sum of the forces equations, and solve. Okay, so there's the free body diagrams. And if we look at this and we think logically, the 10 kilogram block will accelerate down, and the 3 kilogram block will accelerate up. So let's write the sum of the forces equations. Sum of the force on object 1, which is our 10 kilogram, going left from right, is going to be, and if you notice, the free body diagrams are pretty much the same. It's going to be tension up, weight down, and that's going to equal M1A. Sum of the forces on object 2, tension up, weight down. Sorry, my little stylus is dying on me. Equals M2A. Okay, so again, we just have to look at our accelerations. They're not both positive. One of them is negative. It is M1A that is negative, so we need to make sure we make that a negative in there. This is a situation where I like to use elimination. So I'm going to go through and change the signs on this top equation. And then I'm just going to subtract through, and you'll see our tension force cancels out. And we're left with the weight of object 1. We'll subtract the weight of object 2. Okay, so remember these are just mg, and you just have to keep them straight. And now we just go through and use algebra and solve. So remember again that your 10 kilogram object would have a negative acceleration because it's going downward, and your 3 kilogram block would have a positive acceleration because it's going upward. All right, last one. This one's like the first one, and you just set it up the same way. You draw your picture, which is my yellow diagram, and then you draw your free body diagram, which is in the black. Go Vikings. And then you write your sum of the forces equation. We'll do that in blue. So the sum of the forces on object 1, which is mass 5, I always go left from right. Tension force is going to cause mass 1 to accelerate. Sum of the forces on object 2, we have an applied force to the right, tension force to the left, causes the second object to accelerate. They're both accelerating to the right due to the right applied force. Right is considered positive, so we don't have to mess with the signs at all. I would go through, use the same old lovely fan of substitution, plug that guy right into here, and solve. So let's do that. And we wind up getting applied force. We're going to subtract our tension force, which equals M1A, and we're going to set that equal to M2A. Now all we have to do is rearrange and solve. Oops. Factor out an A, divide by the combined masses, and that's our equation. Our applied force was 240 newtons. Mass 1 was 5 kilograms. Mass 2 is 15. 240 divided by 20 gives us 12 meters per second squared. Positive because it's going to the right. So now some of you are like, whoa, I thought we couldn't have an acceleration greater than 9.8. This is true in an accelerated frame of reference when an object is falling down or being accelerated due to its weight. In this case, we have an applied force, which is causing the object to accelerate. So all bets are off for any range of acceleration. So it can be greater than 9.8 meters per second squared. I hope this helped. I apologize again for not being in. If you have questions, please shoot me an email. Please correct your homework and resubmit it. That's what your homework is, just to resubmit your assignments that are corrected. Thank you so much. Bye-bye.